The very last cartographic principles that I want to talk about in the course will have to do with the problems of areas and how we map areas when we are trying to map areas that have vastly different scales of areas, or areas that somehow, by their creation, misrepresent the data that lies behind them. This is particularly a problem in small scale maps where the size and nature of the map units can create a whole bunch of different cartographic problems. So I'm going to go through each of these, first scale and then what's called the modifiable aerial unit problem, which you are going to know best in the example of gerrymandering. So first, let's talk about scale. This is something that you are going to have to address in the project that you are working on. And that is that there will oftentimes be much smaller, much more finely mapped areas compared to very large dominant swaths of a map that might have very different set of data. And one of the solutions that's used to solve this is the use of inset maps in a much smaller scale map. And you'll be creating these over the course of this project, and you'll be making something that looks a little bit like this. This is a map that I made in preparation for this project, and it will be somewhat similar to the one that I make on the project video as well. It shows the percent of vote for the Libertarian candidate in the 2014 U.S. House race. And of course, one of the really big problems with a map of Alaska is that you end up with these really large green areas that are precincts that in some cases are as large as entire states of the United States. But then you have very fine, detailed information about places like Anchorage and Fairbanks. And those areas don't show up at all in the map, but you want to be able to represent them somehow. So if you use an inset map like we've done right here, to show the Anchorage area and the Fairbanks area, we can at least give some picture of what's happening in those areas in addition to what we're seeing in the bigger, broader areas as well. The other problem is even more difficult to address, and it deals with the problem that aerial units often hide data at different scales or when they're represented by different shapes. And there's really no solution to this if you are using data that is inherently a part of some sort of aerial unit that is flawed or problematic. Say the precincts, for example, that we just looked at in the map of Alaska voting are flawed in that they collect in one precinct people who vote from a wide variety of political backgrounds, but are overwhelmed by one particular group. We'll never be able to see the sort of minority group that pops up in those areas and the color that might come with the representation of that on the map, simply because the aerial units mask that. And you're familiar with seeing data like this. This is a map that shows the Alaska vote for President Trump or Secretary Clinton in 2016. And you can see that, one part of the state was very strongly in support of President Trump and other parts were strongly in support of President Clinton. But of course, there's a lot more detail than this. And if you drill down beyond the borough level aerial units and start looking at voting precincts with all these insets that we see here, we see a very different situation. And this is a good example actually of a bunch of insets being used in a map. It's a little bit complicated, but I think it's still fairly effective. But what we can see in it quite clearly is that the voting patterns are much more complicated. The classic example of the modifiable aerial unit problem that you're familiar with is the idea of gerrymandering, where you actually create districts that are meant to dilute some other part of data that you want to show. And so in this diagram that shows sort of an idealized gerrymandering set of solutions, on the left-hand side we see 4 districts. They're evenly split between blue and red. But if we shape the districts much differently, what we can do is we can dilute the votes so that instead of there being an even split and four competitive districts, we end up with, in the middle case, the blue only having one district and the red being able to dominate the blue in three, or vice versa. In the one on the right, we have a set of areas being created where the blue is disadvantaged over the red. That's a great example of the modifiable area unit problem. Of course, there's nothing that we can really do about it when we're given shapefiles that have precincts or counties or whatever it happens to be. We're just sort of stuck with that problem in the data. But by using things like map insets and trying to drill down and find the finest level of data we possibly can, we are more likely not to have this problem. So give this a little bit of thought as you get ready to start working on the last cartographic project that you may be doing.